So with the help of this formula, you can find any percentile very easily, very straightforward. Let's say if someone asks you what is the 50th percentile of this data set. So simply, again you will divide these two halves in exactly two halves. Means it will be at 25 and it will be at 75. And when we talk about the 5-number summary, means this will be the minimum number, this will be the max, median, or it is also known as the 25th percentile, this Q3, which is also known as the 75th percentile. Hello friends, welcome back to day 38 of the 100 days of well with Python algo trading. Basically, you can say that from this video onwards, it will be a rebirth of this channel. You will get the content which is more refined, which is more valuable, which is more researched, for sure. I'm trying to optimize my every bit of time, and in order to do that, I will do whatever I can. I will save the time so I can provide you more valuable content. So from today onwards, we will say it T minus 63 and it will go on up to T minus 0. And if you miss any video, then everything is cancelled for sure. I will try my 1000% to not to miss any video. So it's my humble request to you also that please pay attention and give your best in these 63 days and you will see a completely changed you. I can promise that, right? Because you know that it doesn't matter whatever you are right now, male, female, rich, poor, whatever the religion you belong, doesn't matter, because karma is your identity. You will be known by your karma, not by your any other thing. So just give your best for the next 63 days and it will change you completely. So without a further ado, let's get started. So previously we have covered the whole core Python. After that we covered the Python libraries, and now we have started the statistics. In that also we have covered the basic statistics, right? Then in that we covered the types of statistics, that is descriptive and inferential, correct? Then in descriptive we covered the measures of central tendency, in which we covered the mean, median, mode, and other centrality measures, right? And also we have covered the measure of dispersion, in which we cover the range, variance, standard deviation, right? And we have seen the various types of analysis, that is univariate, bivariate and multivariate. So until now we have covered the univariate, and in which we understood how we can plot the graphs, right? And we have also seen the bivariate, but today we will understand how does it really work, how we plot the charts, the scatter plots, the box plot. We will understand the deep understanding of that, because if you understand these, then definitely it will help you in your whole journey of the machine learning, or you can say the quant trading. So this session will be the continuation of the previous session, and today we will learn the bivariate analysis and its graphs, and the multivariate analysis and its graphs, and we will also learn the box plot, the scatter plot, and we'll also learn about the covariance, correlation, right? And before learning all these things, we will learn a very basic but very important concept, that is the concept of quantiles. So without a further ado, let's deep dive in today's sessions. Listen to me very carefully. I will not read the definitions which are mentioned in the books or on the internet. You can find all those bookish definitions anywhere, right? You can search on Google, you can search on ChatGPT. Instead, I will tell you the crux. So once you understand that, then all those definitions will be very easy for you to understand, right? So please focus for a few minutes and you will see the amazing things of the statistics. So first of all, we start with the quantiles. Okay, let me again clarify you that these words are a little bit confusing, but I will try my best to explain you, to make you differentiate between all these words, right? So the first concept is quantiles. The meaning of quantile basically means the size or the amount, right? You can say the size or amounts. The meaning of quant. So the quantiles means when we divide any data set into equal size groups and each group has equal number of items. So let me tell you with an example. For example, you have a data set which contains these numbers 300, 400 or 500, correct? Quantile means you can divide this data set into, if you want, you can divide in 5 parts and each group has equal number of items, right? In this group also we have 1 item, in this also 1, 1, 1, 1. If you want, you can divide this in, let me add another number here, 600. If you want, you can divide this group in, let's say, 3 parts. So it will be 1 part and this will be another part and this will be another part. So now we have 2 items in each group, right? Basically the meaning is to divide a data set into equal size groups and each group has equal number of items. That is the basic meaning of quantiles. And even we are learning the quantitative finance. Quantitative finance means when we are dealing with numbers, and here also you can say the size of numbers, amount of numbers, and like something which is related to the numbers, the number size, the number amounts, right? So when we talk about quantiles, we can divide a data set into multiple ways. So let's understand them one by one. The first way is quartiles. Don't get confused in these words. This is quantile, this is quartile, R, this is N, right? And definitely you know the meaning of quarter. The meaning of quarter means 1/4, right? So I can write here 1/4 means we divide any data set into 4 equal parts. Then we have the next, which is quintiles, Quintiles. So when we talk about quintiles, it means we are dividing any data set in 5 parts. Next we have is deciles. As the name signifies, we are dividing any data set in 10 equal parts. And the last but not the least, we have the most important, percentiles, which means we are dividing any data set in 100 equal parts, right? Percentiles means in $1 we have 100 cents, right? Means percent means 100 parts. It should be very clear with the naming convention also, right? So when we talk about all these tiles together and when we calculate all these tiles together, we have few rules. If you keep those rules in your mind, then you will not make any mistake while calculating any tiles. So we have 4 tiles, that is quartiles, and second we have is quintiles, and third we have is deciles, and fourth is percentiles. We might have other tiles also, but basically these 4 tiles are required for this session and for this our learning. So this means 4 parts, this means 5, 10 and 100. So while calculating these tiles, you have to keep in mind these rules. Very basic rules, but very important rules. So the first rule is the data set should be sorted. For example, you have a data set which is like this: 5, 9, 4, 3, 1, 10, right? Means before calculating any tiles, you should sort this number. So the first will come here when we sort in ascending order. Then we have 3, then we have 4, 5, 9 and 10, right? So the first rule is sorting. That too also from low to high. Basically, you are calculating the location of the observation in the data set, right? So you can write, we are finding location of observation. Third, the tiles, whatever the tile is, they are not the actual value in the data. Not the actual value in data, which we will understand shortly. And the fourth and the last but not the least is you can find any tile with the help of percentile. So you can find any tile with percentile. So now, keeping these points in your mind, we'll start with the further understanding, right? So now in percentile, we have 2 concepts basically. So if you understand that, then this topic is sorted. So the first concept is to find the location of any specific percentile. So let's take an example of a data set which is already sorted, right? Let's say it is 20, 30, 35, 46, then 51, 53, 60, 75, and 80. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and it is 90. So it means we have 10 values in a data set, right? Which starts from 1 and ends at 10, right? And this is the fifth location. 1, 2, 3, 4, 5. 51 is the median, we can say, correct? Okay, now if someone asks the location, so the first topic is location. If someone asks that what is the 75th percentile in this data set, right? So the question is 75th percentile in this data set means the location of 75th percentile in this data set. So to find the location of any percentile, we have a formula which is P over 100 n plus 1. Here P represents the desired percentile, n is the number of observation, means the number of items in data set, number of, you can say, observation. So now it becomes very easy. So the question was 75th percentile. So what I'll do, I'll just plug in all the values, means 75 over 100. N is total number of items, which is 10 plus 1, right? So I can write 3 by 4 multiplied 11, which is 33 by 4, which is 8.25. Means our 75th percentile is at the location 8.25. But when we look at the data set, there is no 8.25 number because we have the 5th, we have the 10th, we have the 8th number, we also have the 9th number, but there is no 8.25, which means our 75th percentile number is somewhere between 75 and 80. So now what we will do, we will interpolate that value between the 75 and 80. So I'll just write these values here, 75 and 80, correct? And we know that our 75th percentile is somewhere between these points. So now in order to find that, what we can do, we can write like 75 plus, we had 8.25, right? So we can multiply with that and then we can find the distance between these, means 80 minus 75, correct? Then we'll be having 0.25 multiplied by 5 and you will get 75 plus 1.25, which is equal to 76.25. But now you will say that this value is not existing in our data set. Yes, that is true, because as per the rules, we said that it is not the actual value in data. It is not always correct that it will be existing in your data set. So with the help of this formula, you can find any percentile very easily, very straightforward. Let's say if someone asks you, what is the 50th percentile of this data set? So simply what you can do, you can write like 50th, means this formula, 50 upon 100 and 11, right? Means 1 by 2, 11, which is 5.5, which will be somewhere between these two values. When you find, you will get like 51 plus 2 by 5, which is a 0.4, and you will get this value, 51.4. So that's easy. You have to practice this. Just practice on few questions and you will be good to go in this topic. So the location of percentile is now easy for you. So please practice with the questions we are posting on the GitHub and on the website, that is multiple choice questions, right? Okay. Now the next concept is the reverse of this. Means now we ask to find the percentile rank. So earlier we were given the percentile rank, that is 75, means the 75th is at which location. Now the location will be given, the number will be given, and we will be asked to find the percentile rank of this number. So let's take the same example. So what I will do, I'll just copy this and paste it here. Okay, and let me remove these values. Okay, now let's say if someone asks that what is the percentile rank of this 60. So for this we have a formula, and let me write that. For the rank, the formula is x divided by n multiplied by 100, and the value of x is the numbers which are equal to x or less than it. Means here we asked for 60, means the 60 is the x, so we have to count all the numbers which are equal to this x or less than it. So here we have 1 2 3 4 5 6 7. So here the x is equals to 7, n is the total number of values. So here if we plug in all the values, so we'll get x is 7, n is 10, and multiplied by 100, correct? So we will get 10, and the rank will be 70th. So we can say the 60 is at the 70th percentile. And we have seen previously that when we find out the 75th percentile, it was between 75 and 80, right? So it should be very clear now. There should be no confusion. Okay, so now let me tell you again a very confusing part, which is the difference between percentage and percentile. So let's say we had an exam and in which the total numbers is 100, right? Means you will be getting the numbers out of 100, correct? On any subject, let's say maths. And let's say now if someone comes and tell you that I got 100% in mathematics, means he or she got 100 out of 100 marks. This is the percentage. Again, if someone comes and tell you that I got the 100 percentile, so if he or she tells you that they got 100 percentile, that doesn't mean that he got 100 numbers. It is highly possible that even if he got 10 numbers, still he got the 100 percentile, which we have seen previously. That let's say if in his class there are only 10 number of students, right? So what will happen now? And if all those students scored, let's say 2, 3, 4, 7, 8, 9, or let's say he scored the highest mark 10, correct? So out of this 100, now this percentage is only 10%. But as he scored the highest marks, means his percentile is 100 percentile. Percentile is 100. Let me remove this percentage sign. Percentile is 100 and percentage is 10 only. I hope it's very clear to you now. Okay, let's take another example. Let's say in a class there are 1000 students. The number of students. Again, they had an exam which is of 100 total marks. Now what happens if someone comes and tell that he scored 50 percentage is equal to 50 numbers, right? 50 out of 100 means 50 percentage. And again, if someone comes and tells you that he scored 50 percentile, which means in this class of 1000 number of students, 500 students scored equal or less than that person, So it doesn't matter that how much they scored. We have a simple inference that 50% of people scored less than that person, 50% of numbers. So I hope now it's very clear to you. Please, if you have any doubt, let me know in the comments. And from next session onwards, what we will do, we will randomly select a person based on a Python, the random generator. We will create a program in which in a list, we enter all the name of the students who have commented and ask the question, and then we will run the program. And whichever the name comes in that Python, we can have a one-to-one discussion on weekends, right? We can schedule that and you can ask any of your queries. So please ask questions and let me know what doubt you have, and you might get a chance for a one-to-one discussion. Now I think we have covered this very thoroughly. And before moving, let me again tell you a very basic thing, which you might have a question in future, that when we are talking about dividing any data set in tiles, how we do that? Let's say if we are dividing it in quartiles. So let's say we have this line, and if someone asks to divide it in quartile means 4 parts, right? Which means first you have to divide this whole line in central. Let's say it is 0, it is 100, then it will be 50, right? Then you have two parts. Again, you will divide these two halves in exactly two halves. Means it will be at 25 and it will be at 75, right? So you can say this is Q1, this is Q2, this is Q3, and this is Q4. Similarly, the rest follows. Let's say the percentile means you will first create two halves, then again 4, then again followed up to 100. Okay, so that was the basic explanation which you might have question or confusion in future. So I wanted to make it very clear. Okay, now let's move to the next very important topic, that is 5-number summary. You must have heard and seen about this topic a lot of times in data science, right? So let's understand this. So first of all, what is 5-number summary? 5-number summary is a set of descriptive statistics which provides a quick overview of the distribution of the data in a data set. It includes the minimum point, it includes the maximum point, it includes the median. It also includes the first quartile and the third quartile. Okay, let's understand this with the help of an example. So, for example, let's say you have daily trading volume, so which is, let's say, $200 million, then 100, then 300, then let's say 150, then on one day it reaches to 500, another day it comes to 50, and then 70. So the first thing is that you have to sort it, right? So you will sort it with 50, 70, then we have 100, then 150, 200, 300, and 500. So now the 5-number summary has 5 values. The first is the minimum. So I'll write here, the first is the minimum, which is equal to the 50. The second you can take is maximum, which is 500. Right? Then you can find the third number, which is median. And we know that median is the middle value. Means we have 1, 2, 3, 4, 5, 6, 7 values. Means this will be the median. So it is 150. Then you have first quartile, Q1. The first quartile means the 25th percentile, right? You can write 25th percentile, or you can say the median of the first half, right? First half is this, and the median of this will be 70 plus 100 divided by 2, means 170 by 2, which is equal to 85, right? So you can write 85 is the Q1. And the last one is Q3, which is the median of the second half, means this median, right? And this will be 300 plus 200, which is 500 divided by 2, which will be 250. Or you can say it is 75th percentile, which is 250. So simply you can say that when we are trying to find the 5-number summary, which is 5-number summary, which means, let's say you have a box. You can divide this box into 4 parts. So this will be the 2 part, and this will be again 4 parts. So you can write here, this is Q1, this is Q2, this is Q3, and this is Q4, right? And when we talk about the 5-number summary, means this will be the minimum number. Similarly, this will be the max. Similarly, this will be the median. Then we have is the Q1, right? Or you can take this one, or it is also known as the 25th percentile. 25th percentile. Similarly, the fifth one is this Q3, which is also known as the 75th percentile. Hope it's crystal clear, right? And just one more additional information, that this Q1 is known as the lower quartile. You can write it lower quartile, and this one is known as the upper quartile, right? Just for the information. Now one more thing to remember, that what is IQR? This is also a very common term in data science or in the quant finance, that is inter-quartile range, right? Which means Q3 minus Q1, or you can say upper quartile minus lower quartile. So hope Now these concepts are clear. If you have any doubt, please let me know in the comments, and you might get a chance on one-on-one on the weekends with the random Python game. Okay, now based on the 5-number summary, let's understand the box plot, which is also known as the box whisker plot. So if you can see on the screen, we have a box plot and which also displays the 5 numbers. You can see here Q1 means 25th percentile, Q3 means 75th percentile, and then we have the median, which is Q2, right? And on the sides we have minimum value, which is this one, minimum, and this one is maximum. And on the last we have whiskers, which is the mustache of a cat, or you can say the facial hairs of the cat, right? These are the whiskers, kind of this, of a cat, right? So these whiskers are known as the outliers, or you can say extreme values of a dataset, right? Now we have a question that why we use the box plot. We have 3 answers for you. The first one is the find the outliers, right? These are outliers. The whiskers are outliers, correct? The second one is to find the spread of data, right? And the third one is the skewness of data, right? We will understand that how we are doing these things. The whiskers represents the outliers, right? Then we have the minimum and maximum, which represents the spread, and the skewness is represented by the median. If the median is shifted on the right, then we can say it is a little bit skewed on the right, and if the median is on the left, then we can say it is a little bit skewed on the left side. Let's understand this one by one. Okay, so before that, let me answer one more question of all of you, that how we can use this box plot in the quant trading, right? So with the help of box plot, we can compare 2 assets, the performance of 2 assets. We can also analyze the performance and volatility of any asset, right? And the third one is we can use the box plot to identify the outliers, right? So now let's understand how do we create our own box plot. So what we will do, we will have a data set, and then based on that, we will create our own box plot. Generally what happens, we use the tools, the Python, R language, but here we will create our own box plot manually, right? So first of all, we will take a data set, right? So purposely, I'm writing this in ascending order, right? But generally, the first step is to sort the data. Let me write here, steps to create box plot, correct? So the first one is sorting of data. So let's say we have the trading volume of a Bitcoin. So let's say we have $5 million, then we had 50, then 60, 70, 85, and on one day it was around 135, and also it reached one day 160, 170, 180, and on one fine day it reached around 1000, correct? So we have 10 values here, 1, 10, and this is the 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now the second step is to find the Q1, Q3, median, which is Q2, and the minimum and maximum value, right? So Q1 is the 25th percentile, Q3 is the 75th percentile, and Q2 is the 50th percentile, right? So let me write it. So first of all, we have Q1, which is 25th percentile, and the formula for that is 25 divided by 100 and plus 1, which is 11, correct? So I'll get 11 by 4, which is 2.75. And now we know that it is between these numbers, right, 2 and 3. So for that, what I can do, I can write 50 plus 0.75 and 10, which is 50.75, which is 57.5, right, which is equals to Q1. So now we have first value Q1, which is 57.5. Then the third is Q3, which is 75th percentile, which is 75 divided by 100 and plus 1, and we can say it is 33 by 4, which is 8.25, right? And we can say 8.25 will be somewhere here, right? So I can write here 170 plus 0.25 multiplied by 10, which is 170 plus 2.5, and which is 172.5, and I can write Q2 is equals to 172.5. Let me remove this and let me write Q3. Correct? So out of this box plot, we have Q1, we have Q3. Now let's find out the fourth point, which is Q2, or you can say 50th percentile, or you can say median, right? So you have two options here. One is to directly find out the median, means these are 10 values, so you can take 5 and 6 and you can find the mean of these values. So let's try that, which is 85 plus 135 divided by 2, which is equals to, let's say 40. It will be around 220, 10, and it will be 110. So the median is 110. Let me try out the percentile, right? So Q2, which is 50 by 100, and n plus 1, which is 11, and it will be 1 by 2, which is 5.5. It means it is somewhere between this 5 and 6, right? So I can write like 85 plus 0.5 multiplied by 135 minus 85, which is 50, I guess. And if I do that, I'll get 85 plus 25, and which is equal to 110, right? So it's exactly the same. So we can write like Q2 is equals to 110. So now we have Q1, Q2, and Q3. Okay, let's draw the box plot a little bit. So we can draw like this. So we have all the values of the box, right? We have Q1, Q2, and Q3, which is 110 Q2, and Q1 and Q3 is 57.5, 57.5, and Q3 is 172.5, right? Now we are left with first the minimum value, right, which is here, the minimum and the maximum, and then we have the whiskers, right? So we need to find the value of minimum and maximum and the whiskers. So now the formula, let me write the fifth step. So now the fifth point is to find the minimum, right? Q1 minus 1.5 IQR. And we have discussed already that IQR stands for interquartile range, which is Q3 minus Q1. So, okay, let's take an example and create our own box plot, right? Earlier, we used to create with the help of Python or R, but now we will create a box plot manually. Okay, now let's take a data set first. So let's say we have daily returns in percentage. So I can write daily percentage returns, right? Which is equal to, let's say, a list 1, 2, 1, 3, 4, 5, 3, then 50 minus 40 and 2. Let's say these all are in percentage, right? Now let's try to create a box plot for this daily returns, right? So first step is to sort this data. So the first step is sorting of the data, sorting. So I can write like the lowest value, which is minus 40. Then I can write 1, 1. Then we have 2 and 2 twice. Then we also have 3, 3, done. Then we have 4, 5, and 50. 4, 5, and 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the first step is done. We have sorted our data. Now, the second step is to find the Q1, Q2, and Q3. So I'll find first Q1, 25th percentile, right? This means 25 divided by 100, n plus 1, which is 11. So I can write 11 by 4, which is 2.75, correct? This is Q1. So I can simply write Q1 equals to 2.75. And let me, okay, now let's find the Q2, which is the median, or I can say 50 percentile, which is 50 by 111, and 11 by 2, which is 5.5, right? Which is Q2. So I can write here Q2 is 5.5. We'll find out the values after that, don't worry. And the last one is, so Q3 is 75 percentile, means I can write 75 divided by 100 and 11, which is 33 by 4, which is 8.25, and I can write Q3 is equals to 8.25 location, right? Not the number. Now we'll find the number. So let's first find the Q1. Q1 is 2.75, means it is somewhere between these 2 and 3, right? Now, how can I write this? I can write like 1 plus 0.75 multiplied by the distance 1 minus 1, which is 0, means we are left with 1 plus 0, which is 1, right? So we can say Q1 is equals to 1, the final value, right? So I'll write here Q1 is equals to 1. Similarly, for Q2, this is at the 5.5 location, but we do not have any 5.5. So I can go 1, 2, 3, 4, 5. So it is somewhere between 2 and 3, right? So I can write 2 plus 0.5 multiplied by 3 minus 2, which is 1, and it is 2.5, right? So Q2 is equals to 2.5. Similarly, Q3 is at the location 8.25. I can go here, and it is somewhere between 4 and 5, right? So I can write like Q2, which is 8 plus 0.25 multiplied by 9 minus 8, which is 1, and this value is 8.025, which is equals to 8.25, and these are the values we have, right? So now we can create a box plot, but not completely. Let me draw a half box plot. So we have this, right? And we know that this is Q1 we have, this is Q3 we have, and this is the median we have, which is Q2. Now we need to find the minimum value and the maximum value and the whiskers. So here we have the minimum and here we have maximum, and then we have to find out the whiskers, which are the cat's mustache, right? So the third step is to find out the minimum and maximum. So minimum is Q1 minus 1.5 IQR, and we have already learned that IQR is the interquartile range, which is Q3 minus Q1. So I can write like Q1 is equals to 1 minus 1.5 IQR. IQR means 8.25 minus 1, which is 7.25. So now let me calculate this. So it will be 1.5 multiplied by 7.25, which is 10.875. So 1 minus 10.875, which is equals to minus 1 equals to negative 9.875, right? So you can write minimum is equals to negative 875. Let me highlight this minimum. The last is maximum, right? The maximum is Q3 plus 1.5 IQR, right? Which is Q3, we know that it is 8.25. So 8.25 plus 1.5 multiplied by IQR is 10.875. We will get the value as, so maximum is 19. So we can say minimum is from 9.875 to maximum is 19. So this is a range, right? But we know that our numbers are minus 40 to 50. So now how we can draw that? We know the minimum value we have got is, which is 9.875, which is here. Minimum is minus 9.875. That calculated value, right? The maximum minimum. So we have calculated as 19, right? So these are the minimum and maximum. Now we have the outliers. Outliers means whatever the numbers outside of this range which we have calculated, those are considered as the outliers. Means here in our original data, the 40 and the 50, the last ones, these are outliers, right? And we can represent them with the help of whiskers, right? So here are the outliers, minus 40 and positive 50 here. So this is the box plot we can draw, and I can show you Python also. Let me show it. So what we'll do, okay, I'll quickly go and I'll create a series here. So pd.series, and here I'll pass this list, right? And I can give it, let's say the name demo box, right? So when I check this, we will have a demo box, and which is this series, right? Now what we can do, we can simply draw a box plot on this. So I'll write plot plt dot box plot, and here I can pass the series that is demo, and when I run this, you will see the box plot, And you can see here the positive 50 is outlier, and also the negative 40 is also an outlier, and the box plot is here, and here you can see the maximum, the minimum, and the median. And if you want to also verify, what you can do, you can use a describe function. So demo.box describe, and you will see that we have the minimum, which is minus 40, the maximum 50, the median is 2.50, which we also got the same. The 75 percentile is 3.75, we also got, but we got 8.75, and Q1 is 1.25. Maybe there was calculation mistake and you got the point, right? The main thing is you should able to understand this. Okay, and in future we will encounter this a lot of times, so we can again revisit this. But for now, this is the explanation. Please practice the questions which we are gonna put on the website and the GitHub. These will really help you, and we'll also put a mini project. So it's completely up to you that how hard you can prepare and how best you can give yourself. So this is for the day, and I'll see you in the next video. Until then, bye bye, take care, have a nice day, and just be the best version of yourself.